Hey guys, it's Miss Bell here in the Science Lab, and we're going to talk about light energy. We know that light is something that we can see with our eyes, and light comes from all different types of sources. Some that are natural, that occur in nature without ever being made by someone or a machine, or they are what we call man-made or artificial. Those are light sources that are made by humans and machines, such as a flashlight with a light bulb, or a strand of lights that you plug into a wall and then they blink and light up and it's fun and
When
festive.
we're talking about light energy, we know that light travels in a straight line, but we can't ever really see those straight lines. We can see where the light is coming from, whether it's the sun or a flashlight or a candle, but we can't see all those straight lines on even how they get reflected or even refracted. However, with this short demonstration, I'm going to show you a way that we can see those straight lines of light. I'm going to use a laser pointer and a spray bottle of hairspray. I am going to turn down the light, so it's going to get a little dark, but I need you to be able to see the laser pointer hitting the wall. Here we go. Okay. So here's my laser pointer. When I turn it on, you're able to see that beam of red light hit the wall, but you can't see the line of light. I can put my hand in the way like this, so I'm blocking the red light from hitting the wall. But if I take my can of spray like so and I spray it, we're going to be able to see that beam of light that's hitting the wall. Here we go. And with this short demonstration, you're able to see that straight line of light going from my laser pointer all the way to the wall.
In these next couple of demonstrations, I'm going to show you some more examples of how light travels in a straight line. Now, light will continue traveling in a straight line until it hits an object. Now, if light can go through an object, usually that object is clear or see-through, we call that transparent, then light will go through that object and it will create either no shadow or a very, very light colored shadow. However, if light travels in that straight line and comes in contact with an object, then the light cannot go through that object. Sometimes it might bounce off and go in a different direction, like a reflection. Or the light might refract, which just kind of means it makes something look broken or kind of wobbly shaped. But we are able to see shadows because of light. And our biggest light source is the sun. Even though it's so far away, we are able to see objects all around us because of light energy. Whoops, sorry for my spelling mistake. So with this light demonstration, I have a line of CDs held up by clothespins, and I put these CDs in a straight line with the last CD having a target, orange and pink target. And I'm shining my light source, which is from a flashlight, through the middle holes of the CDs. And those light rays are going through those middle holes, and I'm able to see my light shine on my target in my last CD. Here's from the perspective of at the very end, as if we're the target looking back through those holes from where the light source is coming from. You can see I'm moving my light source from left to right, and you can only see it when it goes on the outside of the CDs, because the light we can see through the hole and we can see on the outside of the CDs. However, when the light, either the candle or the flashlight, is in line with the CDs, those CDs are opaque. They're not see-through, so the light cannot go through those CDs because it's being blocked. And here's another light source from my laser again. I'm pointing it through the holes of the CDs that are lined up, and I'm trying to hit that target on the very last CD. Now if I move my CDs in the middle, left to right or up and down, you can see that my target stops shining, or sorry, my laser stops shining on my target on that last CD, because the light stops because it hits that CD. You can also see some of those reflections bouncing off the CDs and making those lines on the table.
So with this setup, I just have a plain white sheet of paper. I have a comb that's in place with some Play-Doh, and then I have a mirror back here. For my light source, I'm going to be using a flashlight, and this is just a quick demonstration to show again that light travels in straight lines. So I turned on my flashlight. I'm able to shine my light from behind the comb, and we're able to see that light shining through the comb. And you can see how it's not going through those dark, opaque, black pieces of the comb, but instead it's going through the little open slits. And you can see that as I'm moving my flashlight from left to right, that the light is in line with my flashlight. I can move it this way, I can move it that way, and you can see the movement of the light because those light rays are traveling in a straight line. Now I've put the mirror there so that you can see from the back side of the comb, because we're able to see the front side and not much is really going on since that's where my light source is coming from, but you can see both versions of this quick demonstration. If I put my hand in between the light, some of the light is blocked because the light is traveling to my hand and stops at my hand because we can't see through my hand. Or I can cover up all the light. And I can keep doing this demonstration. I can keep moving the light around to cover up some of the light or none of the light, but we definitely get a better sense and a better visual of the light that's traveling in straight lines. When we play with light energy, we know that light travels in a straight line, and we're able to make shadows because of the light that goes through opaque objects such as my hand. The light can't go through my hand. That's why I'm able to make a dog or a duck, quack, quack, quack. And there are different types of objects that we can look through and try to see if we can see through those objects. Look at this tape. You can tell from the white background that you can see through it. This is clear plastic tape. We would call this type of object transparent. So these are just some bullet points to remember when discussing light energy. Remember, light energy uses the sense of sight, something that we can see with our eyes, turning on light or turning off light, or getting close to something that's being lit up versus backing away and getting into the darkness. Now, light does travel in a straight line until it hits an object, and it might make a shadow, it might bounce off, it might make things look broken or weird. And light can also be found in different types of ways. It can be seen from natural things like the sun, the stars, a firefly, or it can be seen from things that are man-made or artificial, made by humans or some sort of machine, like a candle that needs a wax and a wick, or a flashlight that needs batteries and a light bulb.
And here's one more quick little experiment that you can do. I cut a small hole at the bottom of a plastic water bottle, filled it with water, and then used my laser pointer off to the side and toward the back to try to hit the hole with my laser. And as you can see, that light looks like it's dancing all over the place. It's actually reflecting through the water, kind of bouncing all over, and it looks like the light is traveling through the water and to my hand.